Okay, the first part you need to know is that 1 mole is equal to 3 other things. It can be equal to the mass of a compound, which would be the formula mass in grams, and that's found by adding up the masses of each element on the periodic table and accounting for if there's more than one of that element. 1 mole can also equal 6.02 to the 23rd atoms or molecules. That it also can equal 22.4 liters of a gas. So then you can use these values to convert between the same substances between any of these 4 items. You can convert between moles, grams, atoms, molecules, or liters. So looking at your first problem to calculate here is 475 grams of potassium sulfate. Convert that to moles. So the first process is to always look at your unit and the compound that's given and bring that down to the bottom as the unit and compound that needs to be divided into itself to cancel out. Then you look at what am I asked to solve for and place that unit on top. In this case it is moles, and it is still the same compound, K2SO4. Then based on the units you have on top and bottom, you go up and you find out, okay, I've got a mole, so I need to place a 1 in front of the mole. I've got the unit grams, and that reminds me I need to have formula mass added up for the particular compound that's in the problem. So that means for this problem you have to add up 2 potassiums, 1 sulfur, and 4 oxygens masses off the periodic table. And that mass is 174.258. So now you're ready to do your calculation. The grams of K2SO4 is divided by grams of K2SO4 on the bottom to cancel it out. So your answer should have the unit that's on the top in your answer. The math in your calculator is 475 divided by 174.258. You should be getting the answer of 2.73. moles of K2SO4 as your answer. The next problem is asking you to convert from grams of the iron oxide, solve for atoms or molecules. So grams of the iron oxide is the unit compound that needs to go to the bottom, so to divide and cancel out. You're asked to solve for atoms of the iron oxide. So that means on top you're plugging in the items that are in front of atoms is 6.02 to the 23rd to plug in. And again, the reminder that in front of grams you need formula mass. So that means you got to add up that you have 2 irons and 2 oxygen. Not 2 oxygens, but that you have 3 oxygens. Masses off the periodic table, and that mass from the periodic table added up would be 159.687 grams. So then your math is multiplying 93.45 times 6.02 to the 23rd divided by 159.687. You should be getting the answer of 3.52 times 10 to the 23rd atoms as your unit of that compound. Be sure that whenever you plug in times 10 in your calculator, you're not hitting times 10, but that you're using the key EE and using that correctly anytime you have a number with a times 10 in it. So in the next calculation, you're asked to convert from moles of AgNO3, so that should be the unit substance down to the bottom. And you need to solve for grams of AgNO3. So that means in front of mole, you should be plugging in 1, and in front of the grams, you need to add up your formula mass of the AgNO3 for 1 Ag, 1 nitrogen, and 3 oxygens masses off the periodic table. That value is 169.872. So that'll allow your moles to be canceled out by moles of AgNO3 to equal 188.73 grams of AgNO3. And the last calculation on the page requires you to convert from atoms of nitrogen gas to liters. So on the bottom, you've got the unit of atoms of nitrogen gas, and you got liters of nitrogen gas. So that means in front of liters, you need to plug in your 22.4, and that is equivalent to 6.02 to the 23rd as your number you need to plug in front of atoms. That'll allow atoms to cancel out with atoms, convert it to liters. So you start out with your multiplication of 9.58 to the 24th power times 22.4 divided by 6.02 to the 23rd power. You should be getting 356.47 liters of the nitrogen gas. Top of the next page, determine empirical molecular formula definitions, look those up. Then on the next question, 15, from the molecular formula C6H6, determine the empirical formula. Well, all you have to do there is reduce your coefficients. So the C6 and H6, 6 goes into both of those once, so my empirical formula is CH. Write the equation you use to calculate the percent composition in any compound. Well, you should be taking the individual element, each different element that's in the compound, separately calculating for its percent. By taking the mass of that individual element and accounting for if there's more than one of those as the top value divided by the formula mass times 100 to solve your problem. So on 17, you should be calculating for magnesium's mass of 24.305 grams for 1 magnesium, divided by the total formula mass of 58.319 grams for your entire compound, then times 100 to solve for your percent of magnesium. And that's going to identify that you have 41.68% magnesium. Then you've got to repeat the process for oxygen and hydrogen, accounting for the parentheses outside of the OH having a 2, meaning you have 2 oxygens. So you've got to repeat the process with 2 oxygens on top, divided by 58.319 times 100 to get oxygen's percent. Then you've got to repeat the process to get the hydrogen's mass. So you've got to repeat for each different element. Question 18. You got to determine the empirical or molecular formula based on the percent that was given. So following the cheat sheet that we did, we said that there are several steps that you have to follow to go from percent and figure out the formula. The first step is that you need to convert and just rewrite any percent, write it to grams. So that means my 32.8% chromium is just 32.8 grams. And my 67.2% chlorine is 67.2 grams of chlorine. Step 2, solve for moles. So that means I've got to convert these each to moles. So that means I've got grams, and this would have been chromium as my element there. Grams of chromium down here, grams of chlorine on this one. Each one of them needs to go to moles of the respective element that's there. So I need to go to the periodic table and get my formula mass to plug in front of my grams for chromium. So chromium is 51.996 grams. That's equal to 1 mole of chromium. I divide 32.8 by 51.96, and I get this value. Remember, we kept all of our numbers in our calculators for that mole value. And then this one, I need to go to chlorine and get its mass off the periodic table to plug in here. And that's equal to 1 mole is my conversion. So I have to have 67.2 divided by the 35.453, and I get 1.8954672338 moles. So now I compare these two values as my next step. And I divide by the smallest of the two. So this value is the smaller one. So I'm going to divide out by this value into both of them. That'll cancel out moles. So I get on this first one, 1.00. Remember, you need to carry this to 2 places after the decimal so you can look for the decimal point places that might need to be multiplied. This one, once you divide it, is exactly 3.00. But remember, I need to look for 0.25. If that's present, I multiply everything by 4. I need to look for 0.33 or 0.66. If one of those are present, I multiply everything by 3. And I need to look for a 0.5. And if I have a 0.5, I would need to double everything by multiplying it by 2 in those decimals. Since I don't have that, then that means my formula then brings down that chromium is just one of them. And then on my chlorine, I have 3. So that's my final formula of my compound.